Okay, so I can see few of around 25 members have joined this webinar today. And as you all know, in the last week, we have launched a series of webinar for the students. Okay, my colleague Parag is back. Hi, Parag. Thanks for joining.
Yeah, hi Mayur. Good morning.
Yeah, good morning. So yes, respected professors and fellow engineering friends. Good morning, everyone, and I welcome you all on the behalf of our engineering group, our Engineering India, for this second webinar of the series of webinar that we have launched for you guys. And in this webinar, you will be looking at one of the advanced uh, 3D technology substation design software, which is called a Substation Design Suite. Just let me know, Parag, if you can see my screen.
Yes, it is visible to you, visible to me, sorry, and I can see the first slide here.
All right, so I guess it's 11:01 now, and we should begin with the presentation by the time everyone will join. Okay, so yeah, greetings again. Welcome you all on the behalf of our engineering group. And I would like to introduce myself. My name is Mayur Bhate, and I am working as sales executive for Substation Design Suite. And I represent this software in Indian region, Bangladesh, and Nepal, and nearby Indian countries. I look after sales and after sales or pre-sales services, and I have with me my colleague Mr. Parag. He is a technical executive application engineer, and he looks after technical side of the software. He provides technical support and helps with the training and after sales services and assisting the substation designers to get adapted with this advanced 3D technology very easily and fluently. As you can see on the screen, this is agenda for today's discussion. I mean, my presentation. So I hope in the last presentation itself, my senior consultant, my boss, Mr. Dugeshan Naikar, has already introduced about eye engineering and what eye engineering does. But I would be I will be repeating the same, but I will be giving a brief information about what eye engineering does. Not I will not go into much deep. A little bit introduction about spatial business system, then substation design suite software, uh, and following with my presentation, my colleague Parag will be demonstrating the how the substation is being designed in this software live. So just I would request everyone to stay along with us. It's gonna be a 1 hour session, but I'm definitely sure that it will be very fruitful and learning session for you all, and you'll definitely learn some new things today, and that will be definitely benefit in your coming future in your career. All right, so a short information about engineering. Engineering India is specialized in providing different software solutions to power utilities, manufacturing industries, especially in electrical engineering domain. We are having our offices in India, Australia, as well as in Fiji. In India, we have two offices, one in Pune and one in Chennai. The softwares we offer are, as you can see on the screen, SDS, which we are going to discuss today. It is an 3D substation designing software with many automated things that helps us do the substation design much faster and in an efficient way. Uh, Automated utility design, this XGS lab for thing, lightning and EMFI studies, then NIPLAN, CAL software, and we also provide engineering design and technical sourcing, as you can see on the screen. All right. So that was all about our engineering. A short information about the company that looks after the development of this software. Uh, act- uh, the company that looks after the development of the software is SPS, Spatial Business System. It is a USA-based organization, and they are working very closely with Autodesk company. You guys may know the company that develops AutoCAD and Revit and Inventor, such kind of software. So SBS and Autodesk, as well as us, our engineering, are very closely associated with each other, and we look after the development and marketing and introducing and educating about this new technology to substation engineers, substation design engineers all over the world. Um, that so so the goal of so the aim, our aim to, I mean, why do we want substation design engineers to use this software? We want them to use this software to deliver smart, sustainable, and safe utility services, which helps to reduce the cost and accomplish more work in lesser time and maintaining 100% accuracy. All right, so coming to the main part of the today's webinar. Here we offer actually two modules for substation designing. The one is the first one is physical design module, which is responsible for the physical design of the substation, and the second one is protection and control module, which is responsible for the protection and control side design of the substation. Um, and as I mentioned before that this software is offered by Autodesk, hence this application runs on, the physical design module runs on AutoCAD, Autodesk Inventor platform, and the protection and control module works on AutoCAD electrical platform. So this this substation design suite add much more intelligence to these two Autodesk products, and that that helps in substation design eventually. Now, why 3D? Normally, normally, the substation design that that companies do are into 2D. They actually use AutoCAD. Okay, so but why do we want to 3D? Why do we want them to do into 3D? There are some advantages that 3D technology brings for substation design, and that is what I'm going to mention over here. So as you can see on my screen on this slide, these are all the advantages. I will be talking about one by one how the 3D technology benefits provide the benefits. And so the first thing, it provides a digital prototype that helps us to avoid costly mistakes during the erection. As we can see the 3D prototype before the erection, you can just have a visibility, have an idea how your substation is going to look like after the actual construction. It gives us clear understanding of our intention behind the design. It also helps us by providing more visibility to potential areas where improvements can be made. The design output is very clear as the drawing generated is of the best quality. The 3D design provides us good visualization of the substation, as we can have a walk through the design and get a clear idea. Migration from 2D to 3D is very easy and very user friendly, as we have 3D models directly available in the library, digital library that we provide. Maintains interoperability with AutoCAD and Inventor, as it is easy to generate 3D drawings using 2D drawings. Maybe sometimes the companies have 2D existing 2D drawings and they would just want to use it and make 3D drawings out of it. So with this software, uh,
Hello?
the interoperability is maintained. Um, and the cost savings can be achieved through design automation, a reduction of problems related to bill of material, and as the design process is faster throughout the project. In case of any change in the design, it can be easily done without changing other data associated with the project. Also, now I'll be talking how Substation Design Suite helps the substation designing companies uh, in the design process cycle, whether for power utility or for consulting firms. So SDS helps to participate in the tendering as it produces accurate bill of material, which gives the precise cost of your project, and it produces high quality of drawings and documentations with all the required details that is necessary within a very short period of time. That helps an engineer to get a clearer idea, and he can accurately provide the details in the bidding process. All right. So yeah, maybe you guys must have been, I mean, you guys must be aware about what is Greenfield and Brownfield projects. Greenfield, but I would like to just give you a brief idea of what it is. So Greenfield projects are those where where you have a piece of land and you have to build a substation from scratch. And brownfield projects are such, or brownfield substation, let's say, are such where already you have a substation and you have to uh, uh, perform. Let's say in some cases you have to increase the capacity of the substation. So in that case, maybe some things has to be destroyed and reconstructed again. So such kind of projects are brownfield projects. So yeah, and this software, Substation Design Suite, also is very useful in such kind of brownfield kind of projects. We can utilize, I mean, a substation designer can utilize the existing data by scanning the existing drawings and editing it by raster design tool. It is a tool that is basically aware into Autodesk software that you can research some other time. Then we can utilize the existing 2D drawings and convert them into 3D layout using 3D design tool made available by Substation Design Software Suite, Substation Design Suite, sorry. If let's say we don't have anything, we don't have any existing drawings, or we don't have any existing data of a brownfield substation, of an existing substation. So in that case, there is another technology, or I can say there is another technique that can be used to create the existing substation. That is point cloud method. Uh, this is, in short, I would like to say a laser scanning of the existing substation is done, and the exact substation can be, the drawing of the substation can be taken out of it, and that can be used for the design process. And I would like to suggest you guys to note down any keywords that you find that you have not heard before, and you do some research yourself. Like for example, here I would like to uh, suggest you guys to search about point clouds, so that you'll get a deeper idea of how these kind of technologies are being introduced in the market and helps in you know modernize the design process. All right, let's move to the next point. So this software uses iterative engineering and design methodology. That is, we can make any changes uh, in the design, let's say during or after the design process at any point of time throughout the project. And it also provides a true link between multiple disciplines, that is steel structure, foundation, trenching, grounding equipment, Then we have 2D and 3D drawings available according to our needs. We can we can use it maybe for it it may be for editing purpose, or maybe passing it on to the actual site and asking the commissioning people to work on it. Uh, by using these techniques, the effort required are very less as compared to 2D drawings or AutoCAD drawings, we can say, as we have standard templates that you can just copy paste, and ribbons and substation specific tools are readily available in this software. Then intelligent cross references are also available. As we have 2D as well as 3D drawings, we can utilize it whenever, whichever needed, as I said before. And also, this software helps us with concurrent engineering, that is, two or more engineers, two or three or more engineers from different departments can work simultaneously, cooperating with each other throughout the project. So, in short, with this software, we are going to save much amount of time that goes into change management, and that of course helps in the reduction of the time, and of course the reduction in the cost. All right, so this software is also capable of designing gas insulator substation. I hope you guys must be aware about what is gas insulated substation, and this software is also capable of doing it. I mean, this software is, as gas insulator substation is something, a growing technology. This what should I say? The symbols, let's say the 3D symbols are still under development, and we are adding it more and more. And yes, um, so SDS can also do the GIS substation design. All right, so now, as I mentioned in the very beginning of my presentation, that the software consists of two modules. One is physical design module, and the other is PNC. Now I'm going to talk about physical design module. And as you can see on the screen, here are some features of the physical design module. So as you can see over here on this image, this is what I mean. These are the images that you will be watching further in the demonstration, and this is actually what physical design of the substation looks like in 3D environment. Okay, so I'll be now quickly discussing some of the features of this module, and so that you get some idea of how this physical module helps in faster designing of the substation. So this module primarily focuses on the physical designing of the substation, as I said. And So here are some of the features. The first feature is bill of material, which is a key element of any project, let's say, or any, let's say, and in this case substation design. Bill of material is a key element, and it is very important that this should be very accurate and extremely correct to get the exact uh, exact things, exact material that goes into substation building, and the exact cost as well that will go into the substation project. So the software creates accurate and customizable bill of material. It counts every small and big parts into the bill of material. It also provides all the information of the part used, such as ERP material code, or maybe SAP number. Plus, it provides civil structure data as well. So, as you can see on the image, this is an example of the bill of material developed in this software, and this bill of material is completely developed automatically. Once you just start doing the design in 3D, the bill of material will be automatically generated. uh, Substation, talking about substation modeling, it helps this software helps in easy and fast modeling of the substation. This software has huge inbuilt library, as I mentioned previously. In Addition to this, we can create our own 3D models using model content editor. Easily, we can use easily the existing projects that we have previously developed, and all these uh, features you will be watching further in the live demonstration. Talking about the trends design, we can easily create a trends design. Maybe sometimes vendor may provide you the existing trenches in case of brownfield projects, so you can utilize that as well if vendor provides you with the drawings of that trench, or we can customize ourselves and create in this software very easily. Talking about grounding grids, grounding grids are special. You guys may know grounding grids are for earthing purpose. So it can be also easily created with this software. We can import uh, we can import 2D drawings, or we can draw it in Inventor. We can draw it into 3D as well. In civil engineering case, SDS can create civil structure designs, and analysis a little bit can be provided for the civil structures. So basically, the civil structures are uh, uh, civil structures are those where the equipments are mounted on, and the buildings that are the control rooms, especially that are constructed. That kind of data can also be made available through this software. All right. So now I will be talking about some design checks, engineering design checks that this software offers. So for talking firstly about lightning protection creation method. Now you guys may know that substations are very vulnerable to the lightning strokes, and it is very important for a substation designer that the substation should be completely protected from the lightning strokes. And this is also an important part of the designing, part of the protection side of designing. So with this software, I mean, this software uses two methods. Firstly, lightning protection by rolling speed and lightning protection by fixed angle. And as you can see on the right side in this image, such kind of images are generated. Um Not images, it is a kind of simulation that you will be further watching in the demonstration, like how we can justify that not any equipment of the substation is being exposed to the direct lightning stroke, and everything is protected further on in the demo that you'll be watching. And talking about the clearance checks, uh, so this software we can easily run a face to face, face to ground, and face to live part clearance check, and we can easily get to know that which part is has not been designed as per the standards, or let's say there is some standard for each and every voltage level that has to be followed, so that there won't be any short circuit or anything, any other fault generated due to faulty design. And additional engineering design calculations, like corona calculation and bus bar design calculations, can also be done using this software. So, and these are some of the features that are recently introduced, like short circuit force calculation, site calculation, cable routing, then cable trees. So these are all the features of the physical design model. Now, coming to the secondary design model, which we use to design the protection and control system of the substation. So the great thing about this module is that its application runs on AutoCAD electrical. Hence, this module is too much user friendly, as it includes all the feature of AutoCAD, plus adding symbol library and tools for automating control engineering tasks, specifically in the substation. If we consider for substation designing, uh, which ultimately is going to which ultimately helps the designer to reduce the lead time of the project. And I'll be explaining few of the features as you can see on the screen. Of course, the BOM generation that I previously was emphasizing on, it is very important part of the complete substation design project or substation design part. It can be automatically generated with all kind of details that you want and with 100% accuracy. It has its own huge library. It has test switch, relay design and editing tools, project-wide editor, raster design tools, terminal strips, cable tracks, tags. Sorry. So ultimately, all these things are going to save time and increase quality with automatic wire numbering, device tagging, error checking, and much more that goes into this side of the substation designing. And it improves not only the efficiency but also the quality of the designers of the substation designers work, of course, by giving 100% accurate data. Now, you must be thinking about what are these test switches and what is this relay design and editing tool and project wide editor and all. And I would like to suggest you guys to just note all these keywords and do some research yourself, or you can just type your questions in the question box, and we'll be discussing all your queries in the Q&A session after this presentation. Okay, so that was all about the important modules that this software offers. And there's one more important module which is this software is offering, and that is actually an important module as far as if you consider for a substation designer's concern. So this module is called as Utility Content Hub. Utility Content Hub is one of the greatest features of the SDS toolkit, as I was mentioning before. And it is having a secure online library of manufacturer 3D component modules, or let's say 3D symbols of the equipment that goes into the physical designing part of the substation. So currently, this utility content hub consists of 10,000 plus 3D symbols and 2D symbols, and the user of this software is having full access to use it anytime. If in case some 3D models are not available as per the designer's requirement, then they can build it on their own. This also is a very big advantage of this that provided by this utility content hub. So basically, what I mean to say is, let's say if in case some transformer is not as per what I'm a designer and I don't have any transformer model as I require, so I can just with some few clicks, you can just modify a little bit in the transformer as per your requirement. Modify in the sense the 3D object that you will be modifying, and you can utilize it easily in your physical design. And this thing also will be demonstrated by my colleague Parag in further on in the demonstration. Uh, all right, so that was about the utility content hub. Then this is there is another module named utility data hub. So basically, this is a platform where physical design and protection control design can be the designs can be brought together, and there are some 30 to 35 design checks that can be commonly conducted, and parallelly conducted, and you can find out if there is if there is some faults in designs, and you can correct. All right, so that was pretty much my last slide. Now I would like to request my colleague Parag to take over this presentation and show the software live, like how the design is being done with the use of this software. Parag, over to you.
Yep. Thank you, Mayur, for your presentation. So I have just opened my Autodesk Inventor Substation Design Suite software. So if everybody can able to see my screen, just let me know.
No, Parag.
No, Parag, we are not able to see it.
Okay, just a moment.
You will have to share the complete screen. So when you
Right.
navigate between the tabs, we would be able to see that.
Okay. Is it visible to you now?
It's coming.
Just a moment. Yep. Now it will be visible, I think.
Yeah, we can see it. Yes,
Okay.
yes.
Okay. Thank you. Thank you. Okay. So hello everyone. Myself Parag here. So as you can see on the screen, this is the Substation Design Suite primary model. We call it a physical design of substation. So basically, this Substation Design Suite is based on Autodesk Inventor platform, and this is what you see the Inventor, interface. So on the left hand side, you can see this whole substation assembly is, subdivided into, different sub assemblies, right? So you can see there is some fence assembly. So it only includes, one foundation and, let's say a fence post over here. And this is something very small, right? Again, if we look further, we have got few lightning masts placed in the substation assembly. You can see some above grade assembly, which includes the transformer, buses, foundation structures, etc. Below grade assembly, which currently includes the conduits, right, and pull boxes. Like those are reference in my below grade assembly. So this is how we have just structured to get a better view, or let's say to control in an efficient manner a whole substation assembly. More, we will look into few more details about this substation assembly. So j- first of all, I would like to show you about this transformer here. So these are the pre-built 3D models, as you can see on the screen, that have been inserted into this substation layout. And further to the transformer, we have got these structures, then isolators, as you can see, and then the from isolator we have just added few buses and extended, to for let's say the feeding this, let's say, the substation to the outgoing side. So I will just go ahead and show you how can we can place 3D equipments using Substation Design Suite tool. So we are first of all making some electrical connection between, let's say, this transformer terminal towards the buses, or let's say towards the isolator. So I'm going to open this assembly over here, the above grade assembly, and you can see we have got few fittings already added at the transformer terminals. So let's say the first terminal we have currently, for an example, shown with a fitting for single bare conductor, and just for another example, we have added a fitting for dual conductor, and we are going to make a connection between this point towards the let's say isolator uh, using the tool sets that we have in the Substation Design Suite. So I will just go into my above grade tools and then choosing a bare cable fitting from my, let's say, library, or in case if you have into your directory or let's say machine, you can simply browse to particular fitting. So basically we use fittings for making electrical connections, connections for rigid or round buses as per our choice. So I will just go back to the place where I have got the fittings. Okay. No, fitting. Okay, fine. All right. Okay, I've got a separate folder actually for adding those fittings. So you can see I have got one fitting model for, let's say, single bare conductor cable. So I'm gonna simply choose that particular fitting from my library, and now you will notice how the tool will behave basically over here. So you can see we have got this NEMA pattern to fix that particular fitting, and now the tool is saying to select a NEMA face with 2, 4, or 6 hole pattern. So all we have to do is simply select that particular face, and it will automatically place the component that we have just selected, which is the single conductor fitting. So it will automatically add that component, as you can see, but the orientation is reversed over here. So I will just go further and use few other tools to rotate this particular assembly. So now it has properly fixed on my NEMA pattern, but still we have to work on the orientation. Let's say entirely in the opposite direction. So I will just click on No button, and it will again ask us whether the orientation is correct or not. So it now looks correct to me. So I'll just say yes. Okay. So just before proceeding further, just let me know if you all can see my screen and I'm well audible to you, because I'm getting few notifications here.
Parag, you are loud and clear, and your screen is perfectly
Okay.
moving,
Okay.
perfectly.
Okay. Thank you, Mayur. So as you can see, this is how we can easily place components, manage their orientations, etc. in with Substation Design Suite tools. So I will just repeat the same procedure, but I'm going to add a dual conductor fitting over here. So going back to the same place, browsing the fitting, but for a dual conductor. So we have got this preview window over here for that particular component we are selecting. So now this safe core AFNC2-20-4B is what the fitting I'm looking for. Again, choosing that particular fitting, choosing a face to mount that fitting, and it will automatically add that fitting on the chosen face. So I will just go back to my above grade assembly, and we can see the modifications made over here just by using these updates. So this is how we can simply add fittings in let's say Substation Design Suite. So we will now look at how we can make electrical connection. That is by adding some bare conductors, bare cable conductor. So we have got various tools to make those connections. Out of which I'm going to choose this tool, pick two fittings to add cable. So now you can see the tool is saying to select two cable fittings. Simply choosing the first one. Now it is highlighted with the green color. And after selection, it will turn to blue, as you can see. Again, selecting the next fitting, and it will make the connection automatically for us. So basically, we are simply, telling few, let's say two fittings in this case, but the tool is automatically looking at their, connection points and even the settings that we have given, like let's say the required sag, etc. And as per our settings, let's say what type of cable we have to basically add in here. So all these data are checked by the tool, and then it will automatically make the connection, as you can see on the screen. So I will just go ahead and make another connection for a dual conductor cable over here. So before that, we will first of all look at the properties we have, default properties we have set for making those connections. So in here, you can see I have got the above ground settings for, let's say, all cables. Now we are going to insert a dual cable. So I'm going to look into my dual cables. And in here, for basically, we have got the choice to select a default spacer model, right? And then let's say if we go in on a previous level, we can, choose the conductors from this list as per our choice. And there are few other settings like related to the sag and, NEMA hole fitting tank type, etc. So what we are more interested is, the dual cable setting, which are related to the spacer setting. So you can see the distance from fitting to first spacer. It is, set as 10 inches, and few other settings like maximum allowable distance between the spacers and cable length with no spacer that have been shown over here. So we are going to keep the default settings over here. Then again, choosing the same tool, pick two fittings to add a cable, choosing those fittings, and the software will make a connection over here. So it will take a couple of seconds, to make that connection. I'm really sorry for this delay over here. So you can see, as per our settings made and the chosen conductor and fitting type, it will automatically, make those connections. And these are the spacers you can see. So I will just go ahead and add few components on my, let's say, these structures. So we have got this structure over here, and we are going to mount few, let's say, the insulator we can see on the left hand side. So I will again go back to my above ground tools. Oh, sorry, the substation design tool. I'm going to browse some specific component from my library. So go back to the place where we have got the uh, equipment. And I think over here, we have got the model over here, which is looking similar to this. Again, choosing a face to place that component. Okay. And you can see it has already placed this component as per our selection. So I will just go further and add another fitting, but for a rigid bus. Again, going back to the same place, choosing the fitting for rigid buses. Equipment and okay. Okay, now this looks similar to what I already used. So I'm going to click on open. Again, choosing a face to place that particular component, which is the rigid bus fitting. And the orientation looks correct to me. So this is how, we can use with our, let's say, components that are available in our library. But let's say if user is interested to, add components that are repeated in our substation, so they can simply, use the component from, let's say, their model tree. So I'm going to simply copy or, simply drag and drop into my model space, let's say, the set of components or group of components, you can say, and all are, fixed as we have, let's say, dropped into here. So this saves, plenty of time of users basically. So in case, let's say, if you want to place this group of component at our desired place, I'm going to again use the tools provided by Substation Design Suite, choosing the component and choosing the place where we have to place the component, right? So now we will look at how we can make, connections through the rigid buses. So again, going back to the tool set available for making those connections, pick two fittings to add, let's say, a desired bus. So basically we can, add round buses, flat bar buses, angle buses, integral web buses. So I'm going to choose a round bus, choosing the fittings, and it will make the connection, as you can see. So I will just save this assembly and we can look at the changes made into our parent assembly. And we will see now few more examples related to, other kind of buses that Substation Design Suite provides. So I'm going to open this assembly on the right hand side, you can see. So to open this, I have to change my priority, choosing this assembly, and then simply opening it to make some modifications into, this side of, let's say, this structure. So you can see we have already added an insulator over here, and there are few, let's say, pin type insulators. So you can see we are going to make few electrical connection through rigid buses, but there is some different in elevation, at two different points, let's say. So basically, substation design tools, understand the elevation difference, and it will, automatically, let's say, make the orientation in, let's say, the buses that we are going to place. So I'm going to choose, let's say, the flat bar bus over here, choosing the top, sorry, choosing the top point of my insulator. Okay, just a moment. I will rerun my tool. So now I have picked the top surface of my, let's say, this insulator, which is at some different elevation, and let's say the top surface of my another insulator. And I have chosen a flat bar bus to make a connection between those two. And you can see, as per the elevation difference, it will automatically, orient our flat bar bus and it will make this connection. Again, we have got a few other examples, but the, let's say, insulators that we have used are at, are of same type and at equal elevation. So I'm going to go ahead and choose this angle bus, choosing the faces, and it will make the connection using the angle bus. And we'll see another example for integral web bus. Again, okay. Okay, the tool is selected and we are simply choosing the faces to make this connection over here. Again, simply saving the same assembly over here and all this dependent assembly. And we will go back to our main assembly to see the changes made. As you can see over here. So this is how, how easily we can make connections or place equipments in our, let's say, 3D model. And all these placed components and equipment, let's say, they hold some intelligence, behind those 3D models. So we will see as we move further, we will see how we can, make use of all these added components into, let's say, different discipline and in our calculations. So I will go back to my main parent assembly over here, and you can see the changes made over here. And all are updated from our substation from our sub assemblies of this substation. Again, saving this assembly again. And now we will look at how we can create some, let's say, drawing out of this 3D model. I'm going to select a drawing file, basically a blank drawing. And we will see now how we can, automate the process of creating, drawings, let's say the isometric or orthographic or, sectional views from our 3D model. So before adding the drawing, I will just change my sheet and to, let's say, a 0. And I'm going to simply place the substation assembly into my drawing. So choosing the base and then the assembly that we wanted to, add over here. So you can see I have simply chosen the right hand side view of substation, then the top view, then the side view, and let's say the isometric projection over here. And even you can see we have got different options to add details, let's say, basically into the particular views. So I just keep all settings as default. But in case if you want to know more about what can be done with this views, or let's say representation of this view, you can simply look into Inventor, like drawing creation, etc., and you will get even better idea on that. So I will just say okay, and it will automatically add those particular views in my, let's say, the drawing, as you can see on the screen. So in case you can see now this is the top view and all the details have been shown over here. The radiators, the connections we have made through, our bare conductors, single and then double. So this is the location where we have got the isolator or earthing switch. And all these buses we have just seen. So I will just go ahead and add few more details related to, let's say, the annotation of this substation. So I will just go into my annotation tab. So these are some tools available, provided by Inventor. So I'm going to choose this, let's say the balloon option, auto balloon option, then selecting a view, and then selecting the components basically in that particular view. Let's say this fitting, and one of the conductor, the isolator, let's say the structure of that isolator, one of the mast, one of the rigid bus, and let's say the insulator, and let's say the flat bar bus, etc. Okay. So once we select all the components that we wanted to, use in, let's say, this auto balloon option, then we can simply choose a placement like this horizontal, around, or vertical. So many options are available. So I'm going to choose, let's say, horizontal, and simply giving it a point to place those balloons, and just say OK. And you can see all these, let's say, balloons are automatically added, and automatically given with a, let's say, number related to, let's say, particular equipment. So now we are going to, extract the part list from this 3D model. We call it a bill of material. So again, going back to the annotation, and then the part list option, selecting a view, and then we have got few settings again. So I'm going to say OK, and adding the bill of material or part list for my substation assembly. So as you can see in this, let's say, front view, we have initially added the 12, let's say balloon number 12 is pointing towards this transformer. And if you look into our part list, the item number 12, it is belonging to the transformer. The part number, its description is given over here. So this is basically Hyundai Make 230-69-12.6, oh sorry, 47 kilowatt transformer. And we have got the list of, all the rest of the items that we have used in the substation model. So this is how, we can create automatic drawings, and even there are few opportunities to, create details or sectional drawings, etc. So we are not going to cover all, but this is how, we can make use of all the tools available to us. And then next part of my presentation is how we can, do the grounding design or trench design. So I will just go into my, let's say, below grade assembly, which includes this conduit section, as you can see over here, and one pull box basically. So first of all, we will look at how we can add, let's say, the conduits. So I will look into my below grade tools, selecting the tools for adding the conduit. And I'm going to choose this option, drop to port plus path. So I have got one drop location over here from one of my cabinet. And then I'm going to choose a inside circular edge of my pull box port. So I hope this circular edge is visible to you. So I'm going to choose this inside circular edge, and then giving it a path to add the conduit section. So you can see this is how, we can make connections, or let's say add conduit over here, which is ending at the pull box. And in case if you want to see the changes in our, say, the 3D model, let's add this place. Now it is, a better view. So I will go back to again my below grade assembly, and then we will see another example for how we can, make the trench design. So simply saving this, going into the trench sub assembly, and yep, we have got the tool set over here for trench design. So I'm going to use this option, trench from sketch. So we have already, added a sketch on our substation layout. So I'm going to choose this particular sketch, and the trench, parts or segments are automatically, added along the path we have mentioned. Again, saving this trench assembly, and to look at the modifications, we'll go back to the parent assembly. Okay. Okay, it is taking a bit more time. Anyways, you can see the modifications in the below grade assembly as well as the parent assembly of our substation. So we will see another example of how we can create a ground grid design with Substation Design Suite. So I'm going to open this sub assembly for grounding design. Again, choosing the tool to generate the ground grid. Okay. So once we choose our ground grid tool, it will give us, another dialog box to create the ground grid. So these are the settings related to, ground grid elements, but we are going to do some construction. So basically we have got various options, for ground grid design. So in our tool, we provide a configurator over here. So if you mention, let's say your overall length or width, and as well as the mesh spacing, let's say, or mesh size, it will automatically add the ground grid. Or let's say in case if user have any pre-drawn ground grid sketch in, let's say, any CAD form, or even in the Inventor platform, we can simply use our existing sketch and create a ground grid. So just a moment. Okay, so before adding the grid, I would like to show you the sketch we have here for grounding and show visibility. Okay, so this is the sketch on which we are going to add the ground grid, or we are going to use it as a reference for adding the ground grid. So going back to again the tools, then the ground grid tool. Okay, then choosing the option to select the sketch, choosing the sketch, and then updating the ground grid elements. So yep. So you will notice, as the tool, circulates through this, let's say, the grid sketch, it will automatically start adding the components on the model tree over here, as you can see. So once done, just say OK. And as we go closer, so I will just disable the sketch so that we'll get a better insights. Okay. So now you can see this is the ground grid layout for our substation. The ground grid conductors, shorts, ground modes, etc. At intersections. So I'll just save this assembly again, and we will see the modifications made into our, let's say, the parent assembly. So I request all the participants, if you guys have any questions, you can, leave your questions into the chat section of this Google Meet.
Yes, Parag, we have got many questions. Do you
Okay.
want me to read them or you will address them directly?
Uh, I mean, I can address at the very end of my session. We can go through these
Okay,
questions then. Yeah.
okay, okay. There are many, so one by one we can just take up once your session
Yeah.
is done. We
Yeah.
can start.
Sure. So I will just go back to my main assembly, and we can see the modifications, into our, let's say, the parent assembly. Okay. So you can see this is the, updated assembly, which includes all the updates we have done, let's say, related to grounding, trenching, conduits, or let's say the connections or related. And even as you remember, we have added the only the above grade part previously, and now once we come back to, let's say, the drawing view, we get another notifications to update the information that have been changed into our, let's say, the 3D model. So you can see now it will automatically add all the ground, trench, etc. equipments, and it will also automatically update the bill of materials. So I have to rearrange my views. Okay, let's say so. Or what else we can do is we can change the sheet size, or let's say the scaling can be increased. Okay, so I think I have to make it a bit smaller. Okay, fine. So this is how we can make use of all automatic updates in all the reference documents and assemblies and even bill of materials, etc. So once we make all the our design ready in, let's say, the 3D model, we can create automatic drawings, as you can see on the screen, bill of materials. So all this data can be exported into different formats like 2D PDFs to and 2D CAD drawings. Even in 3D platform also we can export all this information. So I will just go ahead and show you another example about the design checks. So I will just rearrange my assembly. So we will just take few more minutes and then we'll look into the question and answers session. So you can see this is the design checks option. So here we have already, let's say, specified the high side and low side faces of our substation model. So we can simply click on show button. So it will tell us those particular, added components belonging to particular phase. So you can see at the high side of my substation, this is the first phase and all the components that have been added. Then this is the phase B and then the phase C. So we have only added, few components for an example. Then in case if you want to see the grounded components, we can simply click on this show button. If any components are missing, we can add it into our design checks tool, and then we can run the calculations. The grounded structures you can see on the right hand side, and then these insulators basically you can see over here. So this is how we can, let's say, reference all these components for as per their, let's say, type. Then the next step is to run the calculations. So you can see with Substation Design Suite primary module, we can run face-to-face, face-to-ground, face safety clearances. So just for an example, I will run face-to-ground calculations. So based upon a model, it will take few couple of seconds, let's say, to run the calculations and give us the report. So we'll just wait for a few more seconds to see the calculations for face-to-ground clearances. Okay, I think the results are available to us. Okay, so you can see we have got all these results over here for phase two ground design checks or clearance checks. So you can see first of all we have got the first column over here telling pass or fail. So we can see all these check boxes are marked. That means our substation assembly has passed in the phase to ground clearance design checks. So you can see the required separation is 25 inches. The separation that is currently allowed is 98 and different for a particular group of components. So let's say if we click on this show button, it will tell us the part number, like those two parts, and the basically um, the ground clearance basically, and it also highlights those parts in our model. So in case if you want to, extract those calculations, you can simply use this copy button and you can simply place into your Excel sheet or, any report basically. So this is about, the design checks, and we will see another example for lightning protection. So I'm going to choose this rolling sphere method, giving it some inputs, that is the lightning mast. And as per, our selected, let's say method, which is the rolling sphere, it will add the, the let's say protected volume geometry based on all these top points or let's say lightning mass etc entities, top points. So it is basically creating this geometry as you can see on the screen. So if you found any part of on any equipment or any part of equipment lying or protruding this protective geometry, we can simply say that that particular part is still exposed from a direct lightning. So we have to take protective measures related to this lightning protection, like adding a few other masts or etc., or rearranging even the switch yard to take all these equipments into the protected zones. So this is how this is a short overview. There are few other intelligence behind there are few other options to work with this model. So because of this time limit, I will just stop with my live demonstration, and now we can, I think, look to the question and answer session. Okay.
Wonderful, Parag. Thanks for demonstrating the software live. We have got too many questions, and
Okay.
I appreciate you all those who have asked us these questions. So I think we should start from the very first question, which is what are classification of substation on voltage level or functions associated?
Right.
So I guess the answer to this question is, of course, substation are being classified on the voltage level, but most of the times the substation are classified based on bus schemes. They this I mean it can be classified. There are various schemes, like single bus, main bus and transfer bus, then double bus, double breaker, double bus, single breaker, ring bus, then breaker and half, and so these are kind of configurations that goes into substation classifications. I hope that satisfies your this answer satisfies your question. Then the next question is from Mr. Uday Kulkarni, Substation Design course free. Very sorry to say so, but we are not exactly into substation design. We are actually mostly into this 3D side of thing. But what we do is we actually educate the substation design engineers working into companies like L&T, Siemens, and we actually help them to migrate from the old 2D technology to this latest 3D technology, and we teach them how to design the substation on this software. Does engineering provide? So the next question is, does engineering provide substation design course? No, sir. Very sorry. We do not provide substation design course as of now. But yes, we are planning to introduce this module, I can say, very soon, and we'll let you know. Um, all right. So the next question is, can you share a video link? Yeah, sure. We can share the link with you. But what I can more suggest you is you can just simply visit to our website ieng.tech. You'll find more information about software in the website itself. And of course, we have also got some links over there for more videos and more information about this software.
Mayur, just a sec. Could you just show the slide where you have the details of your website and your contact numbers so that students
Yeah,
can visit
sure.
your website as
Uh,
well?
Yeah,
Keep it
sure.
on the screen. Yeah.
Yes. Parag, could you please just type the website? ing.tech, please.
Okay, it is here. Is my screen visible still? I mean, the
Yes,
second
yes,
tab for
yes,
engineering. Oh, okay,
yes,
nice.
yes. That's why I requested you to show so that we can quickly answer this
So you
question.
can see you can simply type ing.www.ing.tech, and in there on the home page you will find different panels on the top. So if you are interested in any software products and their let's say detailed information, you can simply position your mouse and you can simply choose any product. So I have chosen Substation Design Suite over here, and you will see the some more information related to the substation. Now you can continue, my.
Yeah, just I would request you to scroll down a little bit more. Uh, there's an option over there named Read More. You can just simply click on it. It will take you to the other website, and you will find more videos, more content, and more information about this software. All right. I hope that that will help you with your question. And so the next question is, can we simulate fault currents? Okay, so as I have been mentioning since the beginning of my presentation, that this is just a modeling software. This is just a designing software. We cannot, I mean, this is not a simulation software. So yeah, the answer for your question is no. We cannot simulate fault currents. But generally, just for your knowledge, I would like to mention this that in the substation, I mean, during the substation design process, they have many Excel sheets. They have got many Excel sheets for such kind of calculations, and one of them is for the calculation of the fault current or short circuit current and all. So based on that, they select everything. They select how the spacings and what type of conductors and all they will be using it. So yeah, uh, that is the answer for that question. Okay, so next is, in relay design, can we do relay coordination? Okay, so answer is again no. As I said, this is just a designing software. So you can, the basic, the main intention behind providing this software to design engineers is, if you guys maybe have some little bit of idea, there is I mean, designing any substation, let's say in our case, is a huge headache. There are many people involved in designing one substation, and very minute things has to be kept into account. It has to be checked to ensure that there won't be any fault further, because as you know, substation is a very important component in the complete power system. So the this is, I mean, with this software you can just, I mean, with this software just you can automate the design process. At you can speed up your design process, the accuracy, the, I mean, let's say if there is some 30 to 40% of chance of human error while doing 2D design, then that actually, I mean, we actually can eliminate that 30 to 40% of human error by using such kind of automated tools. So yeah, this is the main motto of introducing such kind of technology to design engineers, so that they can reduce their burden, their stress, and work efficiently. So the next, coming to the next question, which company use this software in India? Is it approved application to use? Share certification also. All right. So currently in India, 3 to 4 companies are using this software. I would like to name the names are Siemens India Private Limited, Siemens India, then Neilsoft Private Limited, Neilsoft India Private Limited uses this software, and the other company that uses is Linkson India Engineering Private Limited. And yeah, we are into discussion with many companies. We are, I mean, our products are into trial phase at their company, and very soon very soon we will be adding more valuable customers, more major players from the Indian substation design industry to the SDS list. All right, so share certification also. All right, so is it approved application to use? Yes, it is approved application. This application is very famous in USA. It is very famous in Australia as well. We have got key utilities, key utility players, using this software, and they have found a huge benefits using this software. Talking about this certification, I just have to, check with my senior consultant, and we'll get back to you regarding that question. Is AutoCAD Electrical a free software to download? Could you demonstrate how to design a substation using AutoCAD Electrical? So, as I mentioned in my presentation, all right, I mentioned the second thing. All right, so first thing is you can for to know whether AutoCAD Electrical is free or not, you just can visit to Autodesk website, and you can find more information over there about AutoCAD Electrical, because we are just responsible for selling Substation Design Suite. We are not responsible for Autodesk, Autodesk product, unfortunately. But yeah, as I mentioned in my presentation, we are closely working with them. Uh, can you demonstrate how to design a substation using AutoCAD Electrical? So as I mentioned in my presentation, the second module offered by Substation Design Suite, named Protection and Control Design Module. That module is actually works on platform of AutoCAD Electrical, and unfortunately, due to time constraint, we won't be able to show you, because that is another huge product, and there are many features, and showing everything will, I mean, showing few things won't make any sense. uh, but anyways, you can just watch the videos on the website, and you'll surely get the idea by I mean of how this product works, how the PNC module works. All right, the next question is, which electrical standards are used for building substations? Parag, I request you to answer this question.
Building substations. Okay, so basically there are different types of substations are there and different kinds of standard. Let's say if you are interested into, let's say, grounding design of substation, and even as per different levels of voltages, there are different standards. So it is sometimes hard to tell an exact standard, because it is more related to the installation standards. Let's say you have to follow related to the substation. Let's say if you if because someone has asked about relay coordination, I guess for
Yeah,
that purposes, there are different standards and guidelines provided. So substation is basically composed of different things. So for each particular thing there are different standards. So you can visit to IEEE, then you will get maybe bit more information over there related to which standard you can refer to.
yeah. All right. So I hope that this answer satisfies this question. Can so the next question is, can you design substation from first step? Yes, of course we can design substation from the scratch. The reason being, I mean, behind Parag using an existing 3D model is because, of course, the time constraint, and we just didn't want you to get bored of watching this whole process for build. I mean, whole process from the scratch. So that's why straight away we actually got this a small 3D layout in on the screen, and thought of showing some key things that is necessary to highlight, and that pretty much sums up what SDS software is all about. So the next question is price of this application. It seems complicated. Seems models are already created. Can you create model in this application? All right. So the very first question is price of this application. So for that you need to contact us individually. I cannot disclose it over here. It seems complicated. No, it is absolutely not complicated. If you are if you are familiar to the Autodesk products, if you are, let's say, if you have had some hands-on, if you know where you can find some ribbons, some tools, then I don't think so. That's I mean, it is just, of course, every application requires some sort of training prior you get very used to it. And we do provide those trainings, but once you purchase this software, not without that. Uh, and Yeah, so it is not complicated, it is easy. Models are already created, of course. Models, see, uh, a substation design engineer won't spend his time to create a 3D model from the scratch and then utilize into the 3D design. That won't make any sense. The overall idea of providing this software to substation designers is to save their time. We are actually providing a digital library, 3D library. A digital library. It is for a purpose. All the models are present over there, almost, and you can just drag it and just use it. All right. So next question is, student version available? No, it is not available. What components or equipments are used in this substation and their significance? Of course, the components, I hope you must be aware of the components used in the substation, and you can just figure out yourself their significance as well. I don't think that needs to be mentioned over here. Are there any standards followed, or we create standards? I think this question has been answered before. There are many standards for the substation design already available, um, and based on that, this software is developed. What are the main equipments and accessories used for substation? I think you can just figure out by yourself. If there is any specific thing you want to know, just please type your question again. In rolling or cone protection, can we add or remove an component where protection is not required, or can we add building or office next to substation and do lightning assessment? How height of lightning mast calculated? Parag, can you please answer this?
Okay, sure. Actually, this question asks us about, let's say, if any equipment lies outside the protective geometry. So basically we can rearrange the mast or shield, etc., or even switcher, in when we generate the rolling spear output or any, let's say, cone protection output, and all this can be managed. And then and later it says that building or offices, like those kind of, let's say, uh, uh,
Control rooms or
yeah, that all
the
this can be added into the model, because the tool set we have provided are specifically for substation design, etc., but it is basically based on Autodesk Inventor platform. So if you know all the dimensions of your, let's say, control room or any kind of structures, etc., we can add those by using the Inventor tool sets provided. So that can be done. And then the next thing is about the lightning assessment. So basically there are, as per country specific, there are some guidelines and procedures given for lightning assessment as per the lightning magnitude, etc. So you can refer to that part, because this is just some hand calculations, but we do not provide any specific tool over here, because this is different for each country. And then how height of lightning mast can be calculated. So basically for this, I strongly recommend you to refer to IEEE 998 standard for getting details about the lightning protections. So this is
okay.
what I can, yep, explain about this. And Mayur, would you like to continue, or shall I go ahead with the
Um,
questions?
yeah. Anyway, as you wish.
Measurements on the sheet. Okay, thank you. Can you show measurements on the sheet? Can you please explain what measurements you are looking for, and what you wish to see on the sheets, or let's say drawing? That's so. Just give us some detail about what exactly you wish to see. So I will just go to next question. Please give some influence of what you showing. We can learn from videos how to connect. Okay. So basically, this 3D substation design is, an intelligent model, because this is what I have shown is related to the automation we are providing. Because most of the 3D or 2D tools you see in the market, basically they involve a lot of, let's say, efforts to add, let's say, equipments, make modifications, create drawings, etc. So all this procedure basically we are making automatic. Like you've seen how we can create automatic drawings, sections, bill of material, and how everything is let's say updating in real time in few seconds, right? So this eliminates all the errors. There won't be any manual errors, so it saves a lot of time of designers on organizations, right? And in addition to this, we do provide like design checks, etc., ability like writing sphere in one single platform. So it enhance the productivity of your, let's say, particular design team. So this is all about let's say the design and automation we provide. But if you look further, the substation model we created is BIM. Like it has all the intelligence or let's say data embedded in each 3D model. So if let's say in addition to 2D drawings, like we usually share to the customer, we can even share, let's say, in a 3D form or any BIM platform like Navisworks or other platform. So this gives better insights to people because all the information is embedded into the models, as you can see over here, related to let's say equipment, and it can also help them into let's say their maintenance, etc. activities, if they look further. So the next question, please. Significant. Okay, that's done. Raju, does the software consider lightning probability? Okay, I think you can refer to lightning this assessment for this case, and then further you can look into the IEEE 998. I'm just going little fast over here because it's we are already half an hour extra here. So please explain basics of grounding conductors. Okay, so we are not doing any grounding calculations over here. We are just doing grounding design over here. So which are important in case of bill of material, etc. So we will see this answer to this question in our one of next session. Can you show where surge arrestor installed in the substation? Basically, surge arrestor, let's say I would say lightning arrestors are in placed where there are incoming or outgoing feeders and near to the transformer. Let's say both sides of transformer you can consider, right? Then can you import AutoCAD Electro Sheet in this application? So basically, I mean, what we wish to import, it's important because AutoCAD Electrical we use for schematic design primarily, schematic and wiring design, not for physical design. Can this be integrated with Google Earth? So okay, so currently we are not exporting this substation layout into, let's say, Google Earth platform. So no, not at the moment. Website is here. Thank you. And please be type for feedback. Okay, fine. So I think we have covered most of the questions. And yeah, someone has asked one question related to Autodesk software. So Autodesk provides student licenses. So you can simply go into Autodesk website and sign up as your student's account, and then it allows you to download the software, and then you can make use of those.
All right, thank you so much for your questions. Those were some nice questions. And if you have any questions more, you can just reach out on LinkedIn or maybe on our email addresses.
Mayur, just one more thing I wanted to add.
Yes,
I think
sir.
a lot of students are asking about training. So I think you should inform them if like whenever any company, especially when they purchase the software, we have 3 types of training we give. One is the self-paced training. Okay, so basically they create an account and they can train how to use this software with the help of video. The second one is we can do online training, and the third one is on-site training. In other words, someone will come to the office, but we don't run any particular like a university or a TAFE type, like a training for students to come and learn about substation design. But we train them regarding how to use SDS software. Okay, so it may be just to make it clear. And the other question, I think there's a lot of questions regarding rolling sphere and all that. Maybe if someone is interested, they can book up another time separately, and then we can answer the question. But just generally speaking, it's based on your striking distance. What is your rolling sphere radius? If it is 20 meters given by the standards or by the utility, that means, to me, I understand the cloud is coming further near the substation, and it can probably damage the device that you're trying to protect. So If it is 20 meter, that means your rolling sphere is much smaller. That means your, the lightning mast will come closer. You may have lot more wires to protect it. Otherwise, the lightning will reach, let's say, the transformer and damage it. So based on the weather condition and everything, the utility will normally provide that to the designer, what to design to. And then what we do in the software is we roll the sphere. We can increase the height and decrease the height to make the thing work based on the rolling sphere, okay, based on the radius for that. It can be 20 meters, 40 meters, you name it, whatever, 60 meters. The bigger the radius means you have, your lightning mast can move further away, okay, because the sphere is too big, it cannot roll in. However, when people used to do this manually, this calculation, it used to take weeks. And as soon as they move the mast to another position, then they have to do it again. This software has got that module. By click of a button, in few minutes, you'll get the answer whether your lightning protection is good or not. So this is how it is done. But anyway, if you have more questions, maybe we can discuss this as a separate meeting. Okay. All right, Mayur, you can round it off, I guess.
Yeah, thank you so much, sir.
Thank you so much, Mayur and Parag. It was really a great session. We learned a lot.
Yeah, you're most welcome. And thank you so much for giving us this opportunity to showcase this software. I hope this was a very fruitful and learning session for you all. And
Yes, it was. We
yes,
enjoyed a
and
lot.
yeah,
And so, guys, see you next Thursday at 11 o'clock with two different softwares. We will be discussing NetPlan, right?
yeah.
So it is a power system design software.
So,
So
sorry,
So I
no.
guess XGS Lab is planned, right, in the next week.
Yes.
okay.
Next week is XGS Lab. You're right. Yeah.
So it is basically an earthing and grounding system studies software. So that too is a very key software, a very famous software that goes into earthing and grounding design. And that will be definitely a good learning session for you all. So request to each and every student to just join this session again in the next week. So for
The meeting ID would be provided to you. I will mail it to you as well as it would be sent on your WhatsApp numbers. Yeah. Thank you so much. Thank you so much, all of
yeah,
you.
thank you so
Parag,
much again,
and
everyone, for
Thanks.
joining.
Bye.
See you again in the next week.
great day, all of you. Yes.